Welcome. So this question says a 2 kilogram ball is attached to the end of a 4 meter long string. The ball moves in a horizontal plane. The string can withstand a tension of 80 newtons. What is the maximum speed the ball can attain before the string breaks? And looking across here, it's a circular motion problem. So let's draw it from above. And here's a tip. Always put your mass at the left-hand side. It just makes the signs a lot easier to deal with. That's 2 kilograms. And I know that this here is 4 meters. And I know I have a velocity. We're going to point it because if it's making a clockwise turning motion, doesn't matter. We're going to call that V. That's what I need to find out. And then I have a couple of other things. One is I have, of course, a tension force, which is enabling this circular motion. And then the other thing I have is a centripetal acceleration, which is causing the circular motion. The tension force pays for the centripetal acceleration, which causes the circular motion. That's the way I think about it. I don't think in terms of centripetal force. I think that's too easy to get confused about. You can believe that because you're going in a circle, there must be a centripetal force, and then you add that to the forces that are already there, when in fact the centripetal force is what you need to get from one of the forces that's already there. It's not an additional force, it's a debt. It's like if you go to Miami, nobody gives you holiday money because you go to Miami. You have to have holiday money if you want to go to Miami and have a holiday. It's a debt. Holiday money is something that you need to get. It's not something you're given. Same thing goes for centripetal force. It's a debt. So I tend to talk about centripetal acceleration and forces that already exist, and it makes life simpler. So if I look at this, I can say, well, the sum of the forces horizontally is equal to ma, of course, because there is a centripetal force, a centripetal acceleration, which is mac. So the sum of the forces horizontally is equal to mv squared over r, because I know that's the definition of centripetal acceleration. Now, when I look at this diagram, I see that plus t, because it's going in a positive direction, is equal to the mass times, and I'm going to do something a little bit funny here. I'm going to say plus v squared over r, because the centripetal acceleration is pointing to the right. It could be pointing to the left, in which case I'd put a negative sign there. This is the advantage of putting your mass to the left-hand side. If you miss that, it's a safeguard. It doesn't cause you a problem. Okay. So then let's put some numbers in. So this is going to be plus 80, because that's the maximum tension that the string can stand before it breaks. And the mass we're moving in a circle is 2 kilograms. And then we have plus v squared over r, of course, is 4. So let's rearrange. V squared is equal to plus 80 multiplied by 4 divided by 2, which equals 160. So V is going to equal to the square root of 160, not 40. So V is equal to second square root 160, which is equal to 12.65. So this is equal to 12.65 meters per second. That's my tangential speed. And do I have it? Yes, I have it. It's there. So there's the solution. We began by visualizing, so we went from words to a diagram. We were a bit careful by putting, we could put our mass on either side, we could put it at the top, we could put it at the bottom, we could picture this in any angular position we like, but by putting the mass at the left hand side, it does make our signs easier to deal with. It's not that it's wrong if it's at the right hand side, it's just that you've got some negative signs to deal with and they can trip people up. Having visualized well, we looked at our relationship and we recognized that when we have the maximum velocity that we can have before the string breaks, we must be at 80 newtons because that's as much as the string can withstand. And the rest was mathematics. It was just basically sums at that point. So there we have it.